This manuscript explores life, death, what lies beyond, all through the lens of classical physics. This process of exploration is a journey in itself, and we have made significant progress in developing this line of thought throughout our previous sessions. In this session, we'll delve into the rationale of calling this Earth ionosphere cavity a heaven. And more importantly, this session will establish the fundamental characteristics of the cavity and its impact on the ELF beams, how it flows down the energy decay, and how it offers opportunities to energize the ELF beam. So, what causes the attenuation or the decay to the energy self while it is in ELF beam form? Let's look at the causes of decay, how these causes generally affect the normal electromagnetic wave, and in comparison, let's understand how the causes of decay affects the ELF beam. Let's start with the propagation loss. The propagation loss affects higher for higher frequencies in Earth's atmosphere, but it affects less for standing waves. And this is the case for general electromagnetic wave. For ELF beam, the impact of propagation loss is pretty less. And particularly, it's extremely less for standing waves. So if the ELF beams are forming standing waves in Earth's atmosphere, the propagation loss is extremely less. Now let's look at the second cause of the decay, the boundary loss. The boundary loss is the kind of loss that occurs at the boundary of the waveguides, the places from where the wave reflects. For a normal electromagnetic wave, the boundary loss will be substantial for higher frequency. But for ELF beam, it is less, and even lesser for low frequency wave of ELF beam. And in our case, the kind of ELF beams we are talking about, that's pretty much most certainly less than 100 hertz. So it's extremely low frequency, even within the segment of ELF. Now, the third cause of decay is the atmospheric absorption. For a normal EM wave, the absorption is significant in the atmosphere and the penetration is low. But for ELF beam, the absorption is pretty low and the penetration is deep. And same is the case for earth absorption as well. And that's pretty much the fourth cause of decay. For earth absorption, for normal electromagnetic waves, it gets significantly absorbed while it passes through the earth. But for ELF beam, the absorption is pretty low. The fifth cause of decay is scattering. For normal electromagnetic wave, the impact of scattering is significant. There are quite a few types of scattering that really impacts the normal electromagnetic waves, like for example, Rayleigh scattering or Mie scattering. But for ELF beam, scattering has practically no effect, no impact. And that's because the wavelength is pretty long. The last cause of decay that we have mentioned here is dissipation. And in most of the cases, the dissipation generates heat energy. So it's usually the heat dissipation. Now, for normal EM wave, there is usually a high level of dissipation. A good percentage of the energy of the electromagnetic wave gets converted into heat during the process of propagation, during the process of scattering, during the process of penetration or absorption. Uh, but for ELF beam, the dissipation is pretty low to extremely low level of dissipation. So overall, if you look at the causes of attenuation or the decay, the ELF beam has most of these causes of decay covered in the Earth ionosphere cavity. There are extremely low level of decay. The possibilities of decay is low, and due to the environment of Earth ionosphere cavity and due to the nature, the characteristics of ELF beam form of energy, the possibilities of the decay becomes extremely less. So, what could help sustain the ELF beams longer in the Earth ionosphere waveguide? There are few possibilities, and we'll discuss about these possibilities while we'll also map these against the different dimensions of beam characteristics. And we will essentially discuss four different dimensions of beam characteristics: the frequency of the beam, the phase of the beam, the polarization of the beam, and the alignment of the beam. And the way these possibilities will get aligned with the beam characteristics, that would essentially derive the kind of gain we could obtain from the situations. Let's start with the resonance. So for resonance, all we're expecting is that the frequency would match. The frequency of the existing ELF beam would match with the frequency of the existing ELF wave available in the environment. Now, that frequency match or that resonance will essentially create minor localized gain for standing waves for the overlapping positions of the waves in the medium. So, essentially, where the ELF beam is overlapping with another ELF wave present in the environment, and in that overlapping position, in that particular area of the medium, there would be some minor localized gain coming out from that frequency match, from that resonance. The second possibility is coherent resonance. In the case of coherent resonance, the frequency and the phase of the beam both will match. The ELF beam would have the same frequency and same phase of the ELF wave present in the environment, and such coherent resonance would usually result into a larger gain by having the energy transfer established. So such coherent resonance could create a situation of energy transfer where some fraction of energy from one of these waves could transfer to the other, depending on the existing intensity of the ELF beam and the ELF wave present in the environment. Depending on the difference of amplitude, difference of intensity, the energy from one wave could get transferred to the other wave, and through that there could be a larger gain achieved by the ELF beam. The third possibility, and it's perhaps the rarest, is to achieve a perfect coherent resonance. In such cases, frequency, phase, polarization, and alignment, all four of these dimensions of the beam would match. So the ELF beam form would have the exact same frequency, phase, polarization, and alignment with the ELF wave that will be present in the environment. And that would essentially lead to a potential convergence of the ELF wave and the ELF beam. So it would be almost like two beams converging and becoming one. And that would essentially create a substantial gain due to this convergence. All these possibilities and the way that could occur in this environment of Earth ionosphere cavity would essentially help the ELF beam to sustain longer, to achieve the energization from the environment in the waveguide of Earth ionosphere cavity. So, in summary, what value the heaven brings to the ELF beams? Well, it offers a secured and guarded space in the form of Earth ionosphere cavity where the ELF beams could rest uninterrupted. Then it offers an appropriate medium that minimizes the loss and the decay of the energy of the ELF beams. And then it generates and hosts oceans of ELF waves of appropriate frequencies that could potentially assist energizing the ELF beams. And then it prepares an environment that encourages harmony to establish the energy gains. And it offers the space and time to the ELF beams to reconcile with their own core beam profile by regaining a coherent identity. These are, in nutshell, the reasons why the Earth ionosphere cavity could be considered as the heaven for the ELF beams. We will develop this line of thinking further in the subsequent sessions. Keep watching.